topic that I kind of discovered for myself over 20 years ago. And I've been telling this story before, so bear with me if you've heard that before, but every year I'm kind of expecting that I would need to look for some other topic to work on because, I mean, web app security, that's not that hard, I think. And therefore, the situation should get better. But the situation does not get better for obvious reasons and not so obvious reasons. And one of the trends in web app security is that the teams behind web browsers, they also understand that the situation is horrible and that supposedly we developers, can't get our stuff together. There are still security issues, so they are continuously adding security features into their software products. So the idea of the talk now is to give you a run through many of the security features in browsers, many of them HTTP headers, but also some JavaScript APIs and more. So if you expect an inspiring talk with vague suggestions what to do next, you may be wrong here, but if you want to have an elaborate checklist of things to add to your web application to increase the security posture of your site, then you're at the right place. And with that, I'd like to start with an attack that's over 25 years old. And the attack has a term coined by the Internet Explorer team. That's how old it is. What is it? Yes, it's cross-site scripting. Now, I went to cvdetails.com, a website that kind of collects common vulnerability enumerations and also creates nice charts how commonplace web application risk or web application attack is by enumerating the times that there is a CVE for that specific thread. Now here's the chart for cross-site scripting. And I mean, people keep telling me, yeah, cross-site scripting, that's a problem solved. But if you look at the chart, I mean, I'm not an expert, but I do see some increase in numbers. And if you look at 2024, we are not even halfway through this year. But if you double the current numbers, so I took this chart sometime last week, we'll have a new record number, maybe even crossing 6,000 reported cross-site scripting CVEs this year. So the situation is horrendous. And of course, many frameworks and especially SPA technologies, what they do is they try to build in cross-site scripting mitigations. So even if you have no clue about security, then you have some level of protection. But of course, it's mandatory to have a clue about security to go from maybe 95% protected to 100% protected. And the actual reason why cross-site scripting is such a big problem is the one sole security feature we have in JavaScript, the so-called same origin policy. Now, I don't like that term because when we talk about origin, at least but I mean, English is not my first language. So, but I think about, where something is coming from, but no, that's wrong. They use origin here as a term defined by the Internet Engineering Task Force. And origin is a part of the URL. It's the protocol, the scheme, and if it's not the default, it's the port. And essentially, the same origin policy states that JavaScript code can only access things, quote unquote, that have the same origin. Origin as in the IETF definition of origin, which essentially means if you have an iframe on your page and that has the URL in there has the same origin as the outer URL, then JavaScript has access to that. That's a good thing, but if we have cross-site scripting, that means that someone injects us JavaScript code, inline JavaScript code, or JavaScript code coming from somewhere else, a script tag with SRC set to some third-party server, maybe under the attacker's control. Now, even though that code lies on a different server, since it is injected into our page, thanks to the same origin policy, it has the same privileges as our own JavaScript code. It's like having a new developer on our team, and that developer can pass code reviews, right? That's what cross-site scripting is. Now, I assume that some of you would like to be in that position, but I think that's a different story. But in general, Cross-site scripting just means someone is adding code to our application. Now, as you've seen from the chart, cross-site scripting has been there for a long time, but somehow the numbers are still going up, although cross-site scripting offenses are common knowledge, I would say. Therefore, web browsers try to add protection to their systems. So the older people in the room maybe have seen this Internet Explorer pop up, right? IE has modified this page to help prevent, okay, that's lawyer speak, right? So we don't guarantee anything. Help prevent cross-site scripting. And indeed, there were cross-site scripting filters. They originated in IE8, a great browser from a security perspective, because really it's sparked a lot of new approaches that other browsers then also included. And well, all browsers except for Firefox, essentially. A filter that had to be fast, otherwise users would complain, and should not provide or report any false positives, because then users would complain. So it was fast and not good. So these were the two design goals of that browser protection, and therefore the protection was always insufficient. Essentially, Firefox was right. Eventually, IE and Chrome, Safari, Old Edge, New Edge, they all removed that feature because there was something, well, new. It's not really new, but it was a kind of a replacement for that, speculating filter. It was something that could give developers of web application control over the execution context, so to speak, of the JavaScript code in the browser. So content security policy is a W3C initiative. It originated with several browser developers working together. Nowadays, staff from Google is helming that. There's a version 1, which was a candidate recommendation 12 years ago. So really old idea, actually. But then it was demoted to a working node. Working node is like, scribbling something on a piece of paper and then putting it in the trash. That's what a working node is. Because version 2 of content security policy became a W3C recommendation, so a standard in 2016, and that version 2 has support everywhere. All modern browsers have it. The only browser that doesn't have it is IE11, but as I said, all modern browsers have it, so all is good. There is a new version 3 being worked on, which adds interesting new features, but that's, as I mentioned, an effort that is helmed by folks from Google, and it's still a working draft. Therefore, all browsers that are not based on Chromium, so everything but Chrome, Samsung Internet Browser, Opera, Edge, they are hesitant to implement those features because things could just change on the spur of the moment, and they won't take that risk, right? So they are waiting with version 3 features. That's why I only would recommend using version 2, or at least make sure that your content security policy is compatible with version 2 so that version 2 compliant browsers can support it. Now, how does such a content security policy look like? I'll just give you an example. You send an HTTP header. There are other options as well, but that's the best bet. You're sending an HTTP header. The header is called content-security-policy, and then you can have a value, and the value may consist of an arbitrary number of so-called directives. Directives are the things with the hyphens in them. So default SRC, image SRC. And each of those directives may have a more or less arbitrary number of values. The values are separated by spaces. That's basically the BNF, so to speak, of content security policy. And even if you've never seen this before, looking at that, you immediately have a hunch what is going on here, right? So default SRC basically says, okay, if you have any resources on that current page, you can only load it from self. Self is a constant, single quotes mean constants, and means the current, there's the term again, origin. So only load stuff from your own origin. So if someone finds a cross-site scripting vulnerability and injects script src equals http third-party attacker server.no /bad-script.js, that would not be loaded because that's not self. Default SRC applies to any kind of resource, but for specific types of resources, you can have specific directives. For instance, here is the image SRC directive. And I don't think you need much fantasy to find out what that is referring to. So if you load images on your page, now you can only load them from self and from HTTPS staticexample.com, right? So this is really content security policy in a nutshell. So I have an enterprise app here, which I'm pretty fond of because it's using a microservices approach to implement or provide great value. And I made that app, which, I mean, as you see from the output, is super simple, right? We have the current time and we have some awesome design in there. But I made it that way so that everything that can go wrong when implementing a content security policy will go wrong, right? Just not to show you that content security policy is cumbersome. No, it's not if your application is built in a good way. But if you have a legacy application that's maybe, shows its age, then there might be some loops to jump through, and I'll just, show you what needs to be done. The application is actually implemented in a relatively simple fashion. So I have an HTML view here. Actually, I'm lifting the logo from the venue where we are at, from the Oslo Spectrum website, so I don't have to pay for hosting, right? Because I'm stingy, and also I thought, I can up the design a little bit by providing a little bit of color and sizing it appropriately. Then I have the placeholder for the output of the current time, and then I'm loading a templating engine because enterprise applications do need templating engines, and then I'm loading some custom JavaScript code, and that custom JavaScript code, essentially what it does is it is calling a microservice, right, and then that microservice returns the current time, and then that current time is sent to the templating engine, and then the templating engine generates the HTML, and then the HTML is injected into the page. That's essentially what's happening here. So every 1,000 milliseconds, a new request to my API is sent. We get the current time, and then the UI is updated. So that's how things look like. Now, if I'm naive and just say, I just work with a content security policy here, so we can just use default SRC, single quotes, self, right? Which just says, okay, load everything from the current origin only, which is a good start. Then if I refresh this, we already see what has happened, right? The image is gone, the color is gone, and most importantly, current time is smaller than before, right? Which irritates me quite a bit. Oh yeah, and the current time isn't there either. So what went wrong here? And again, if you do it right, content security policy is, if you ask me, mandatory because it provides great cross-site scripting abuse protection. I have to phrase this carefully. But depending on the app, there might be some work involved to get the content security policy up and running. It's easier than a new project. You just start with a content security policy. Now, what went wrong here? I mean, there are different reasons. I just would like to give you a glimpse. In general, it's, of course, a good idea to precisely know where your application is loading resources from. For business applications, that's often easier because maybe they're running an intranet, so basically you have one origin only. For publicly facing web apps, that might be a little bit different because, the marketing team just while you were away for a week was sneaking in some tracking pixels. And then, of course, that means stuff is loaded from a different origin. So the content security policy has to care for that. Or just marketing is wondering why you get zero tracking. But again, different discussion which you have to do internally. Now, of course, the first glaring mistake is that I'm loading the image from a third-party server. That third-party server is not part of our content security policy because it's not self. So we try to be as specific as possible. So I'm allowing images from self because I may have a fav icon and from everything within that folder, right? So that would be a good idea. And then if we try to reload the page again, Yeah, the image is there, but somehow the beautiful goldenrod color has gone. Still, I'm getting no time output, so something is off. And that leads me to the biggest impact that a content security policy may have at the content of your page. And that is, I mean, what's the common denominator of the things that do not work? What doesn't work is the color, possibly the size, and also the size of the placeholder down there. These are all inline styles. Now, by default, if you have a content security policy that applies to style sheets, so default SRC is set, or there's a specific directive for style sheets, guess once what it's called, style SRC. So if one of those is set, or both, then by default, inline styles are disabled. Why are they disabled? Because in legacy browsers, you could inject JavaScript code via style sheets. In modern browsers, there are some hypothetical proofs of concepts where you can send data from the page to somewhere else, a keylogger, for instance. I don't really believe in that, because if you have a content security policy, it just doesn't work. But there's a reason why this was made this way. So what does that mean? Well, if you have a modern application, of course, you don't have any inline styles at all. You have your styles in external CSS files anyway. But for older applications, you may need to refactor that. The other option, or the other problem here is that the JavaScript codes we are using is also of a very, very specific kind. What the JavaScript code here does is, we are calling set interval, which isn't a problem, right? So this runs code every n milliseconds, and n is 1,000 here, so once a second. But we are providing the code as a string. In JavaScript, that counts as a call to eval, right? So set interval, set timeout with strings counts as this. Calling the eval function counts as this. Using new function counts as this. Providing a sorting function as a string counts as this. So there are different patterns. This is also disabled. So no inline styles, no eval or similar in JavaScript. And as a consequence of no inline styles, also no inline JavaScript. And I mean, let's look at the positive aspects first. If you have a content security policy, you can't, if you have a cross-site scripting vulnerability, an attacker can't inject script SRC, HTTP, other server.com, well, they could, but the browser won't load that resource. So that cross-site scripting vector closed, it's gone. If someone injects script, alert 1, yeah, they can inject it, but the code won't run because it's inline code. So cross-site scripting, solved. Thanks to browser support, not thanks to our brilliance in making our application cross-site scripting foolproof. No, the browser helped us here. But of course, again, legacy applications, what do you do? And I think just to show you what would need to be done, let's have a look at the values we can use for those -src directives. We can set it to star, well, okay. An origin, a URI, self, we've seen that, and none. So good news, if you do script SRC, that's the directive for JavaScript code, none, then you won't have any cross-site scripting issues. You also won't have any running JavaScript code in your application, so this might be a downside depending on your application, but still. But of course, there are some better things. Now, how do you enable inline? I mean, enabling inline JavaScript code means enabling cross-site scripting vulnerabilities that are present. So don't do that at all. Enabling inline styles, you know, some frameworks need that. And at least in my usual threat modeling, that's not that big an issue, so I accept it. Well, it's not called enable inline because that sounds so positive. You have to think about what you're doing, so the value has to be a prohibitive name so that people think twice before implementing that. So that's why it's called unsafe inline, right? So you have to type unsafe before you're re-enabling inline styles. Don't do this for JavaScript, just do this for style sheets, and only if we absolutely must. Well, and then unsafe eval to re-enable eval. So we could try this out real quick. We have the time. So let's go back to the content security policy. And then for style sheets, I enable self again because, I might have some CSS file, and unsafe-inline because I can. And for JavaScript, I also allow self, and then unsafe eval. Now you may wonder, wait, can't you just refactor your code? Yeah, I might, but well, we'll have a look at that. So let's load it again. And so now you see, okay, we still have that graphic again. The styling works, everything, but we still got issues with the call to that endpoint and the display of the time. And there are several aspects to that, and there's one problem, and that problem is something you have to have on your horizon. There are several issues in here, right? So we don't have time to discuss them all and fix everything, but I have a third-party dependency here. Don't get me wrong. I'm not kind of, complaining about that specific templating engine. It's perfectly fine. But just imagine the templating engine would be used all over the place in your very complex application. That templating engine is using new function internally. So it is using eval. Now here in my application, I just could yank that out and do my own templating. But if you can't, in that case, you really have to enable eval again, and then you have to really triple check whether all calls to eval and similar, whether they only get trusted data as a parameter. Here in my application, that would work because I have an endpoint. That endpoint is under my control. The endpoint returns the current time, so that's digits and the colon. So that would work. In a more complex application, it's just much more difficult. And you just have to be aware of what your application is doing. That's super important. Where stuff is loaded from, and if those dependencies do things that are not recommended any longer, right? So that really is, in a nutshell, how content security policy kind of affects an application. I mentioned it affects it in a good way, because if there's a cross-description vulnerability, it's hard to exploit. Depends on how everything is set up. But by all means, try to implement it. But for a legacy application, there might be more work. And I mean, the elephant in the room is, what if the legacy application has a lot of inline content, especially inline JavaScript? We have a lot of .NET content, obviously, at this conference. So some older people in the room may have worked with ASP.NET Web Forms. ASP.NET Web Forms, yeah, laugh for ASP.NET Web Forms. ASP.NET Web Forms, what they did is they always output a specific block of JavaScript code, the __ do postback JavaScript functions. Yeah, I see a few people nodding. So you've been through this pain as well. That's inline code. But you can't just do unsafe inline for JavaScript code. But how do you make this code running? Because that code was paramount for ASP.NET Web Forms to work if you had a form on the page. There are two options. One option is you create a secret, a number used once. And then in the content security policy, you just use nonce, number used once, dash, or hyphen, and then that random string. Of course, it should be more random and longer than ABC123, but I only have that much space on the slide. You put that in content security policy and instruct the browser essentially, okay, wherever there is nonce equals ABC123, that code is allowed to run, that inline code. Right? So you can do that if you control the script tag. ASP.NET Web Forms, to stay with that example, you can't, you don't control that specific script tag. But there's a second option, and that would work for ASP.NET Web Forms and, of course, in other scenarios. If you don't control the script tag, but you know exactly what the code will look like, because that __ do postback method was predictable, you just calculate the hash of the content of that script tag. And then you put the hash in the content security policy, something like this. So you basically allow a specific piece of code to run. You can use SHA-256, 384, and 512. So a at least as of now, a collision with other valid JavaScript code is, the probability is basically 0. So you green light specific code only. And that, I think that is a great outing for legacy applications, where you can prevent at least some kind of refactoring. And talk about before we finish off content security policy, but it's such a complex thing and so valuable. So that's why I spent quite an amount of time on that. Especially for legacy applications, slapping on a content security policy afterwards is a good thing from a security perspective, but maybe not such a good thing from a UX perspective, because you don't know whether you messed up, whether you forgot something, and then on the production system somehow something does not work because the content security policy makes the browser not load a resource or not run specific code. So you want to know if that happens. And for that, there's a reporting infrastructure. There's a directive called Report URI in Content Security Policy 3 that was renamed to Report 2. But remember, if you only develop for Chrome, feel free to use that. But no, we are using Report URI so far. And that Report URI directive as a value just gets a URI. And whenever there's a policy violation, so a resource can't be loaded thanks to content security policy, or code won't run thanks to content security policy, that URI receives an HTTP post request with information about that failed code or failed resource load as the payload, right? So you get an API call when something goes wrong. And I mean, what are the only 2 reasons? I can't come up with more. 2 reasons for a policy violation. Reason number 1, you forgot something, right? That tracking provider server that the marketing team implemented last week. And what's the second reason for a policy violation? You have a cross-site scripting vulnerability and someone tries to exploit it. These are 2 things you want to know. So, yeah. By all means, use the reporting directive. And there's a second header. It's called Content Security Policy Report Only. And it does exactly what the name suggests. It reports a policy violation to that endpoint you set up, but it doesn't enforce the content security policy. So your application runs as if there was no content security policy. So if you slap a content security policy on an existing application on the production server, use content security policy report only at first, and then, let your customers use the application for a couple of weeks, and then check whether there are any policy violations. If there are, fix the policy or fix the code. And if there are no more violations, enforce the content security policy. So this works a great deal. There is one kind of outlier here, and that is single-page applications. Because in single-page applications, a common trend is that everything runs in the browser. So you load the SPA framework. The SPA framework then comes from self. So the content security policy doesn't protect you there. And then for some reason, there is DOM-based cross-site scripting. So the logic takes data from, I don't know, maybe from the URL, the hash, I don't know. Applies it to the page, boom, you have cross-site scripting. So what do you do against that? And there is something that eventually will help us here. For single-page applications, the basic sink for cross-site scripting attacks is if data is written to inner HTML. There are other options as well, but the inner HTML property is basically where most of the attacks happen. You have some payload. That payload is written into the DOM, is interpreted as HTML, and could be JavaScript code, right? Now, there is something called the Trusted Types API. Bad news first. If you look at the standard, the people leading that effort, they all work for one company. The standard is not done yet, so what does that mean? Chrome, Edge, Opera, they support this. Other browsers don't yet. Still, apply it, because those other browsers will just ignore that feature. And it looks like this. We use a content security policy again, and there is a new directive called Require Trusted Types 4. There's only one valid value, and that one valid value is script. So essentially, what that does is you can't write strings to the inner HTML property. It just won't work. So actually, I think I have an example here. So let's just say I have here some text, and I'd like to write this to inner HTML. So that worked. Essentially, what this means that I could try cross-site scripting here. So how about image src equals NDC on error equals alert 1, right? So you know, script kiddie cross-site scripting. And writing that to inner HTML means, oh, we had cross-site scripting here. Now, if you go to the source code here, and forgive me for just preparing this, so we do save some time. If I add this content security policy header, this I can also use via meter tag, which was faster here, and reload this. And if I try to write something to inner HTML now, it worked here when I output the text, but here when we have the rendered code, it did not work. Why? Because in the console, and I hope you can see that, it said, failed to set the inner HTML property. This document requires trusted HTML assignment. Yeah, because thanks to activating that trusted type mode, I cannot write strings to inner HTML. I can only write trusted strings to inner HTML. And yes, of course, you could create a loop and then convert every string into a trusted string, but at least, you know, this makes you think, should I really write verbatim strings into inner HTML? And a typical pattern, which you could then use, would be this. So you could use the very, very excellent DOM purify library, which has a sanitize method. So you take some input and it just turns this into harmless HTML. And you can configure it so that instead of returning a harmless HTML string, it returns a harmless trusted HTML string, right? And so if you do this, so this would be the button on the right. So let's just try image src equals NDC again. On error equals alert of 2, maybe this time. And now you see that DOM purify kind of sanitized the input, so it got rid of the JavaScript, the event handler. And then this was indeed written to inner HTML. I mean, I have no image here called NDC, but you see that the browser now tried to render an image, okay? And Chromium-based browsers only at the moment, but for single-page applications, this can also be a game changer to really get cross-site scripting under control. So I encourage you to take a specific look at that and consider implementing it in your applications. There is another aspect, and that was kind of embedded into the example here, but I didn't point it out, and that's subresource integrity, another browser security feature. So if you load JavaScript from a CDN, or if you have a CD/CI infrastructure and want to make sure that no one injects in that infrastructure injects some alien code as part of the process. You can set the integrity attribute when loading resources like JavaScript to a hash of the expected content, especially if you pull JavaScript from a CDN. If someone takes over this CDN, they might be able to inject arbitrary code into your page unless you tell them not to. And you could see that right here. So I'm having two dependencies here, Bootstrap for the layout, quote unquote, and the DOM purify library. And you see that I just provide the SHA-512 hash for DOM purify and the SHA-384 hash for Bootstrap. And so if something would change on that server I'm pulling that from, that integrity value, that hash, would not match the actual content of the page, so things would not load. Super simple, but super effective. And of course, it's even better if you don't load anything from a third-party CDN, because then you have a single point of failure there. But if you do, at least with that, you can make sure that you get the content you are actually expecting. The next threat I'd like to discuss is cookie hijacking. If you read on the web, often it's Medium articles about threats, especially about cross-site scripting threats. Everyone says, yeah, with cross-site scripting, you can steal cookies. Now have good news and bad news in the same sentence. If you have cross-site scripting, cookie hijacking ain't a problem these days. It just isn't, because cookies can be secured. The bad news is, if you have cross-site scripting, you still have problems, lots of problems. But cookie hijacking isn't it. So cookies cannot really be stolen. I mean, we have to protect our cookies because often they contain sensitive information, such as a session ID. So we need to protect them. And there are ways to do that. The original cookie specification that Netscape put up in 1994, I believe, here's an archived version, looked like this. So this was taken verbatim from the spec. So we have set cookie as the HTTP header to set a cookie, couple of metadata, and the last one is the secure flag. Even then they thought about, maybe we don't want cookies to be stolen, at least at transport. So we can save them or secure them at transport by using the secure flag. Secure flag says this cookie can only be sent back and forth if a secure transport mechanism is used, so that means HTTPS for our web applications. So if you have a cookie, a session cookie, and then someone goes to http://ndcoslo.com, that cookie will not be sent because it's not HTTPS. So cookie theft can be prevented like this. So we can secure cookies at transport. Can we also secure cookies at rest? Because we have cross-site scripting, right? And if you have cross-site scripting, we can, we can inject some JavaScript code, and the JavaScript code then might access document.cookie. And we see, oh, wait, there are 0 cookies, but I'm pretty sure that the application is using cookies. Well, because there's another thing, originated in IE8, but now works in all browsers. It's the HTTP-only flag for cookies. HTTP-only protects cookies from JavaScript seeing them. And I mean, in most, if not all cases, there are 0 reasons why JavaScript should be able to access cookies, because that's an HTTP feature that the browser kind of manages together with the server, and therefore JavaScript does not need to see this. Just by applying that HTTP-only flag, JavaScript doesn't see that cookie. There are proofs of concept that JavaScript can somehow get access to that cookie if the trace HTTP method is activated at the server, but chances are it isn't, right? So that is pretty nice. And modern browsers also support a relatively new feature, cookie prefixes. If the name of a cookie starts with __host, then it's impossible to inject a cookie that sets the domain flag of that cookie, which is also a nice attack so that the cookie could then be sent somewhere else. If the name of the cookie is prefixed with __secure, then that cookie needs to have the secure flag. If it doesn't, it's rejected, right? So by setting those 2 flags, by applying the secure header and by applying as the secure flag and by applying the HTTP only flag, your cookies have a solid security posture, right? And that's why cookie theft is not a problem. The actual problem these days is if single-page applications do authentication and they have a token, and the token is stored in local storage. Local storage is a JavaScript API. So if you have cross-site scripting, that value is gone. That can't be protected like this. Still, with a content security policy, you might make it super hard to send the token to somewhere else, but still, right? So even for single-page applications, don't use local storage for your tokens. Use the BFF pattern, for instance. Now, we've seen that we can secure cookies by restricting them to secure connections. Is there a way to force the browser to use secure connections all over the place? There are a couple of options. The arguably best option so far is called HTTP strict transport security. It's an IETF standard this time and manifests in an HTTP header called strict-transport-security, which the server sends as a HTTP header and instructs the browser, next time you are talking to me, right? It's like bad parenting. Next time you're talking to me, use HTTPS. And browsers comply. You have to set a couple of options. So for how long shall the browser comply? Half a year, 2 years? And should this also apply to all subdomains? Both are good options, I would say. And if that is set, and a user then say if ndcoslo.com would set that, and a user tries to go to http://ndcoslo.com, the browser would automatically make an HTTPS request instead. So if you do this, only the very, very first HTTP request could be plain HTTP, unsecured. All future requests will be HTTPS. You don't want to do this maybe on your local dev system because, localhost certificates, yada, yada, yada. But on all publicly available servers, that's what you want to use. Also, web browsers these days have a built-in security mechanism in terms as there is a list of domains for which strict transport security is enabled by default. And here on that website, you can add your own domain to that list. So with the next browser update, strict transport security is already on. So even the very, very first HTTP request is a secured one. So just type in ndcoslo.com, for instance, and they say, yeah, please add me. Well, turns out something didn't work when going to ndcoslo.com, so I know it wasn't me. But some prerequisites have been met, and I tried this before, of course. So, and there's one prerequisite NDC Oslo did not meet, maybe intentionally. But if you meet those prerequisites, you can set your own site on that list, and then it's HTTPS forever, which, if you ask me, is a fantastic thing. Yeah. Oh, did I misspell? NDC, also.com, yeah. Why didn't they get that domain? I mean, seriously, cyber squatters. Oh, I have to tell them. Thank you very much. Yeah. So one of the prerequisites is missing. You have to provide a directive in the header. Yes, I want on that preload list, and they didn't do that, or didn't want that. Right? Not a problem, but yeah. That is the reason. Thanks again. Another attack where people tell me, no one, that's not happening anymore. It's cross-site request forgery. But again, looking at cvdetails.com, you see that chart goes here till 1500. For cross-site scripting, it was 6,000, so right, factor of 4. But still, double the number here, and you'll see we will get a new record here this year. So cross-site request forgery is often going like this. An attacker prompts your browser to send an HTTP request to an application. You're already logged into that application, have a session cookie, and the attacker redirects you basically there. And on that request to that other website, all your cookies of that website, of that application, including the one with the session ID, are automatically sent. That's how cookies work. A little bit simplified, doing a request to ndcoslo.com sends all the ndcoslo.com cookies alongside that request, right? And so cross-site request forgery is a dangerous thing. The situation got a little bit better. Yes, I know the numbers don't show that, but all of the frameworks, including ASP.NET Core, they have built-in cross-site request forgery protection. Now, even with ASP.NET Core 8, even for minimal APIs, there's an anti-cross-site request forgery middleware. And you can, prevent this with the use of one-time use-only tokens in the forms, etc., etc. But still, web browser teams decided we need to do something against this. And what they came up with is something with a weird name. So apologies for that. It's called same-site cookies. Yeah, it is called same-site cookies, but I would prefer that they called the API, so to speak, we need to use cross-site and not same-site. Let me explain. There is a new flag, well, relative new flag now, for cookies. It's called same-site. And the same-site flag dictates the cross-site behavior of those cookies. Confusing, yeah, I know. So what is a cross-site request? In my browser, I'm on a.com, maybe like attacker. And from there, I'm sending a request to b.com by being redirected, by submitting a form, clicking on the link, whatever. In the old days, well, for the last 30 years, essentially, that request to b.com would send all b.com cookies, hypothetically allowing cross-site request forgery. Now, with the same site flag, you can restrict that. So when there's a cross-site request, A.com in the browser, request to B.com. Then there are three options. I'll start with the last one, none. None means not that the cookie is not sent. No, that's why it's so confusing. None means no protection. So the cookie is sent, just like in 1994. Lax means, for that cross-site request, yeah, cookies are sent, but only if it's a request that, according to the REST principle, doesn't change the state of the application. Get, head, like Google search result page going to your site. Yeah, if there's already a session open, you may want to recognize the user, so that works. It's a GET request. But for post, put, delete, patch, for those, the cookie is not sent. So if you have cross-site request forgery, it may not be exploitable because on that forged request, if it's a post request, which is often the case, there's no cookie sent alongside if the same site level has been set to lax. Strict is even better. Strict means if there's a cross-site request, the cookie is just not sent. The cookie is just not sent, even for a GET request. And that can be a good defense in def strategy against cross-site request forgery. So no excuse for not having this one-time token in your forms, etc., but defense in def. Like content security policy is defense in def. There's one catch, though. And that catch is, it's called same site. It's not same origin. So what is same site? Same site is, I think, ETLD plus one. So it would be ndcoslo.com or I don't know, google.co.uk. So www.ndcoslo.com, api.ndcoslo.com, and publicbeta.ndcoslo.com, they would all be the same site. So if you have a cross-site scripting vulnerability on beta.ndcoslo.com, that code could send an HTTP request to api.ndcoslo.com, and since this is considered same site, cookies would be sent alongside that request if no matter of the same site setting, right? So make sure you have solid cross-site scripting protection on the whole site, even on those forgotten legacy systems. One more reason to, precisely know your assets, the assets you're using. There is another attack, and that is harder to pull off, and that's why I think it's super dangerous. And that is clickjacking. So clickjacking essentially means I have a page with a button, and I want the user to click on that button. So it could be in an internal system, the user can delete something. I can't, but my victim can. So I lure the user to a site or a web page where the application with the button is in an iframe. I make this invisible using CSS, but the iframe is there. And then if the user clicks on the page, the user actually clicks on the button in the iframe and carrying out that action. Right? I have an example here, but for the sake of time, let's not look into that. I think the description is good enough here. So the problem is that our application can be loaded in an iframe on another site. Right? That is a problem, but once again, browsers come to our rescue. I mean, we could write JavaScript code and find out are we in a frame or not, but let's just the browser do it. Once again, IE8 introduced something, the X frame options HTTP header, which basically says, so this page must not be loaded into an iframe or in a frame if it is set to deny. That means absolutely don't load it in iframe. You can also say same origin, yeah, load it in iframe, but only if the page with the iframe has the same origin as the page in the iframe. That's of course a little bit limiting. So on ndcoslo.com, you would not be able to load something from widget.ndcoslo.com in an iframe. If you need more flexibility, ditch that header, because we have a content security policy now anyway, right? Everyone will have one after this talk. And so just set the frame ancestors directive, where you can basically provide a list of origins that may be loaded in that iframe. All right, there are a few more, and what I'd like to discover next is data leakage via referrer. So there is this HTTP header, referrer, written with one R because there was a typo in the HTTP 0.9 specification, and we are always backwards compatible, right? So that's why that header is always misspelled. But yeah, right typo, right would be refer with double R. And referrer policy is a W3C almost, well, it's a bit difficult. It is a candidate recommendation, so one step before a standard since 2017. But there's also an editor's draft that was updated last December. So they're still discussing which features which browser wants to implement or not. So a lot of politics going on. But the idea is like this. The server sends an HTTP header, referrer-policy, and then basically says, this referrer header, which contains the current URL. So if you click on a link on a.com to b.com, the referrer header would contain the a.com URL and send it to b.com. So if you have a secret intranet and have links to arbitrary websites in there, the URL of your secret intranet might leak by clicking on those links thanks to the referrer header. So you can basically say things like, yeah, just set the referrer header if the target is the same origin as where we are currently at, right? And there are several other options. Not all of them are supported in all browsers, but things like origin or, my favorite, no referrer. I don't need the referrer. The marketing team sometimes needs the referrer to calculate the path through our application, so maybe something like same origin would work. And origin just sends the origin, but not the full path. So you can really kind of narrow down what is being sent, if something is sent at all. And as many of those things we discussed, I think it's very colloquial what I'm saying, but I think, how does the saying go? A lot of bang for the buck, right? So often very little effort. You add a header, relatively trivial to implement, probably no side effects, but the security posture of your application just immediately got better with just, half an hour of work. And refer policy, one of those. There are some other headers where you could debate how much gain you get from them, but still I'd like to mention a few of them. So there was something called feature policy, which was an HTTP header which could restrict which APIs the JavaScript code in an application was allowed to use. So whether, for instance, geolocation could be used, or camera access, or USB access, stuff like that. If you have a big application, but you can't control all of the content in the application, this might be an option. This was now deprecated, so I think Firefox still supports select parts of that. And the successor is called permissions, plural, policy, where the syntax looks a little bit different, but Chromium browsers only at the moment. So it's nice to have, but it doesn't protect everything. And so I think in the end, the goal is that eventually there will be something called a document policy, but it will take some time until the web browser teams have decided upon which route to go. So again, lots of politics, a little bit of stalling. So while this helps, it doesn't help all of your users unless you just say, Chrome is the way to go, but I urge you not to do that for a variety of reasons. I've seen Netscape versus IE, I've seen Firefox versus IE. I don't want to see that again, but I'm seeing it. There are a couple of other four-letter acronyms that manifest in HTTP headers. And they start with cross-origin. There are more than those three, but just let's quickly look at those three because I think they sum up nicely what is possible. So cross-origin embedder policy basically says, okay, if I have content on my site and I'm embedding something, or if I have content on my site and that is embedded on another site. I mean, you have seen an example before. I was stealing the Oslo Spectrum logo and included it on my web application. They could have prevented that by saying, no, you cannot directly include something from that website. So you can set a policy. And in that policy, you can basically say either, okay, everything is good, or you need something called CORP, that's the cross-origin resource policy. So another HTTP that has to be set for the resource you're using. And what the cross-origin embedder policy also supports is reporting. You've seen the report URI directive when talking about content security policy. Well, this is using this new report to directive and a little bit different syntax. But essentially, if something goes wrong, so if someone tries to include your content, then you may be informed thanks to that reporting infrastructure. You can also have a cross-origin opener policy. So the idea is if A.com opens B.com in a pop-up, there is pop-up could also mean new tab, right? Then the open page might to some degree access the opening page, which was an attack that once hit Instagram. Therefore, you could restrict that as well and say, okay, if the open page has a different origin, no connection there whatsoever, which I think is useful. And as I already mentioned, the cross-origin resource policy. So if something can be included as a resource or not. I'd like to discuss one more HTTP header that is kind of security related. I find it useful, but maybe that's my developer heart, or because I'm old. That's clear-site-data. I mean, you know, I have this love-hate relationship with caching. Caching on the server when the server controls it is great. Browser caching is cumbersome. Do you all have this disable browser cache checkbox in the F12 developer tools on? Yeah, I do that as well, but of course the end users don't do that. But with the clear-site-data header, you can, if the server sends that, you can basically instruct the browser to purge certain data from that site, which is great because that really disables some kind of caching. There is good browser support, well, uniform browser support for cookies and storage, local storage, session storage. Chrome itself supports a few more options on Chromium-based browsers. But basically for cookies and for storage, that's pretty neat and pretty comfortable to use that if you're in the situation that you have to absolutely make sure that data is not cached or data is purged from cache. Yes, and I know we have various caching HTTP headers. We can use tricks like appending random stuff to the URI. All good. But with clear-site data, this can be made explicit. Well, and finally, there is this whole topic of authentication. I mean, this would be good for a talk of its own, so you can easily fill over an hour with that. I just want to mention that because it's basically up and coming. So we have the web auth specification. I mean, you may have seen this, right, that if you have a YubiKey dongle, right, you can plug it into your machine, then tap on it, and then you can log in against applications. Sometimes applications aggressively try to want you to use that as well. And an upcoming standard, and lots of applications are nagging you at the moment to do this, is to use passkeys as a kind of a digital credential in lieu of passwords. So people would like to get rid of passwords, which, don't get me wrong, is totally fine. I mean, I still have my reservations, but again, this would be a talk for a different day and time. If you're interested in that, there's a very interesting discussion here. What about passkeys is good, but what the current implementation is basically lacking, and what kind of inherent risk we have, especially when trusting one entity with all of your passkeys. So this just as an inspiration for let's say further reading. And with that, I think we've gone through a lot of content. I think you have a lot of things to look at, things to do, things to read, and there will be more during all of the remaining 3 days of the conference. So enjoy your time here, enjoy the conference. I'm here for any questions, and with that, thanks for your kind attention, and have a wonderful day here at NDC Oslo. Thank you very much. Great to be back. Thank you.